Hello and welcome back to another video on the later concepts of the ACT math test. Shout out to one of my viewers for leaving a comment asking about these to help me realize this should really be its own video, specifically covering rate and speed or distance, rate, time problems. You'll see different things on the internet to call them, but it's just something where you are solving for either the distance, the speed or rate, or the time of something moving, normally a car. As always, if you find this helpful, leave a like, subscribe to help the channel, see when I post more videos, and comments if there's any other topics you'd like to see, any questions you have, or anything that you might want to see as an improvement. But let's get right to it. So for these rate-speed equations, what do you need to know? So the first is just speed equals distance over time. That's the easy formula. If you think of driving, especially here in America, miles per hour is our speed, and that is miles, that's the distance, per, meaning divide, hour. So that's time in the bottom. So that's an easy way to remember this equation. If you wanted to rearrange it, you could just multiply the time over here to get distance equals speed times time. I'll often use this because it's easier to write out in these problems, but it's the exact same equation. You don't have two things you have to memorize here. Now note that this is really just a type of linear word problem. We've covered those before with y equals mx plus b, or in this case we have y equals mx, and there's just no b. B is 0. Y is distance, m is speed in this case, and x would be time. B would be a starting point, which for these it's almost always going to be 0. Technically they could do something with, let's say I was driving 10 miles, but starting at 2 miles from the house for a total of 12 miles. I could have 12 equals mx plus 2 in that case, but you almost never really see that on the ACT, so don't really worry too much about B. This is the formula we're going to have. Now, an important thing to point out for these, especially where you see them on the harder problems, is if you are ever asked about average speed, do not actually average multiple speeds, which I know is confusing because it says right there average speed, and the thing you don't want to do is average things. Instead, use the total distance divided by the total time to get the average speed. So this is just the same thing as up here. I just put average in there and then totals. I'm just going to leave it like this up here moving forward just because it's shorter. But this is what we're going to need to do. So if I'm going to drive a certain speed for the first bit and then a different speed for the next bit, I don't want to average those speeds. I want to get how far did I go for each of those, add them together, how long did each of those take, add them together, and plug them into this. So let's start by looking at some of the simple examples just to see how these equations work, and then we'll get to some of the hard ones. We'll solve for each of the three variables, but they're all going to work the same way. Where they give us 2, we'll just plug in those 2 and solve for the other one. So we'll start with solving for time. Bill drove 137 miles at an average of 45 miles per hour. You'll often see that as mph on his trip. How long did the trip take? Rounded to the nearest hour. So here's our formula again, and I can just plug these in. They told me it's 137 miles, that's my distance. 45 miles per hour is my speed. There we go. I can solve for time by just dividing by 45. So 137 divided by 45 gives me 3.04, or 3 hours if I'm rounding to the nearest hour. So pretty simple here. Let's look at another example, this time solving for speed. Bill drove the 101.2 miles of his commute in 2.3 hours. What was his average speed? Now notice I did say average speed here. This isn't what I was talking about with the warning, because there aren't multiple speeds for you to accidentally go and average here. They only gave you a distance and a time, so there's really nothing to average. But even so, it would be referred to as average speed. So remember, speed is distance over time. So distance is 101.2, time is 2.3, so 44 miles per hour. So now let's go look at solving for distance. Bill drove an average of 55 miles per hour on his trip. If the drive took 90 minutes, how far did he drive? Now be careful here. They will try and do this little trick for ones that look easy. Still not hard, but they will see if you make this mistake. The units of the speed, miles per hour, are based on hours. But the time they gave you is in minutes. That's not okay. We're going to have to convert these to match. So let's take those minutes and make them hours. So take the 90 minutes times 1 hour is 60 minutes, so the minutes cancel out, and that gives you 1.5 hours. So that drive took 1.5 hours. Now I can go and plug this into my formula, distance equals speed times time. The speed is 55 miles per hour. The time is 1.5 hours. Don't put 90 in there, because then your units won't work out. That gives me 82.5 miles, and that's my answer. So, that'll do it for the easy questions. Now let's look at some of the harder things that they might ask you to do. Bill drove an average speed of 40 miles per hour for the first 30 miles of his trip. Then an average speed of 55 miles per hour for the final hour. What was his average speed for the whole trip? Do not average the 40 miles per hour and 55 miles per hour. That is the warning I was trying to give. They love to do this type of a problem. Instead, we need to get the distance and time for both parts of his trip. So this first bit and the second bit. Then we can use total distance over total time to get the average speed. So let's break it up and we'll do the first part first. So in this first one, he did average speed of 40 miles per hour. He went 30 miles. So I have the distance, but I do not have the time. Those are the two things I'm going to need for each section. So let's use my formula. Distance is speed times time. I know the speed, I know the distance and I know the speed, so I can get the time. 30 over 40, that's 0.75 hours. All right, so now let's look at the second part of the trip. This one he was going 55 miles per hour for 1 hour. So I have the time, but I need to get the distance. Again, I'll go right back to the same equation, but now I'm solving for distance by putting in the speed of 55 miles per hour and the time, 1 hour. I'm okay because this is per hour, that's hour. My units are agreeing with each other. So the distance on that one was 55. So now I have the distance and time for both parts, and I can now go get the average speed. So, it's a reminder from that first slide what we found out. Part 1 was 30 miles in 0.75 hours, and Part 2 was 55 miles in 1 hour. So to get that overall average speed, speed is distance over time. So that speed is going to be the total distance, so the 30 plus the 55, over the total time, so 0.75 plus 1, so 85 over 1.75, and that gives me 48.57 miles per hour. That's my average overall speed. Now note that if you did just average the speeds, you would have gotten 47.5, which is close, but it would be wrong, and you better believe this is going to be one of the answer choices, because that's what they're trying to see if you make the mistake doing. So just be really careful never to average speeds to get an average speed. Now let's take a look at a second type of complex problem that they might ask. Bill drove 240 miles at an average speed of 20 miles per hour slower than his usual average speed. If he completed the trip in 2 hours more than usual, which would make sense because he's going slower, what's his usual driving speed in miles per hour? And here's your answer choices. So this one's actually quite complex. Now there is, though, an easy trick to solve it. So I'm going to start by solving it with that trick, and then I'll solve it the normal way so you can see whichever way makes more sense to you. And you can also then see why it can be helpful sometimes to take advantage of the ACT structure and some other ways of solving things rather than what they're actually intending. So what is that trick? Let's just try out the answer choices. Don't solve it outright. You've got multiple choice. Try those. So let's try C first, just because that seems like a logical one for me. Start somewhere in the middle. So C was 50 miles per hour. So if this is a normal trip, because I'm trying to figure out what's his usual driving speed, and I'm saying his usual is 50 miles per hour, well, here's my equation again. If he's going 240 miles, using 50 miles per hour, how long will that take? Divide by 50, I'm going to get 4.8. So now let's see, well, what would his slow trip have been? So his slow trip still goes 240 miles because the distance isn't changing, but he's going 20 miles per hour slower. So instead of 50, I'm going to put 30 here and solve for time. So if I divide by 30, I get 8 as my time. Now, 8 is not 2 more than 4.8. So it can't be C because I'm supposed to end up with 2 hours more than the usual. And if this is my usual, I did not get 2 more. So it's not C. Let's try D next. So this time, 60 miles per hour. So normal trip, same equation, same distance, but now I'm going to try 60. as my normal speed. If I divide by 60 here, that's going to tell me my normal time for this trip, or Bill's normal time, is 4 hours. And then his slow trip, still 240 distance, but he's going 20 miles per hour slower, so 60 minus 20 is 40. Solve for time. Divide by 40, you'll get 6. So, now notice, this time his 20 miles per hour slower time was 2 hours more than the usual. That is what we wanted in the problem. So that's my answer, D. I didn't have to do anything too crazy, I just had to plug in a couple until it worked. Not too bad. So now let's solve this the normal way, also known as the hard way. So this time, let's start with the normal trip. Same equation, distance equals speed times time. I know the distance, it's 240 miles, but I don't know his normal speed and I don't know his normal time, so that's as far as I can go. 240 equals s times t. Can't do anything else with the normal trip right now, so let's go to that slow trip. Same thing, distance is speed times time, still 240. His speed is going to be 20 slower than his normal, so it's now going to be s minus 20. And make sure you put that in parentheses. And I'm multiplying by his new time, which is 2 hours more than usual, so I have to add 2 to this t. Now I still don't know what this s or t is, so that's as far as I can go with this equation. But that does give us now two equations with two unknowns. So these can be solved using elimination or substitution. So if you want, you can go see one of my earlier videos on systems of equations. I believe that was Early Concepts 8. And that will cover how to do those techniques. Now this one is going to be pretty hard for those, which is why it's a later concept and not an early one. So I rewrote those equations right here and we can go solve them. I'm going to use substitution because I think it's easier in this case. So I'm going to solve this first equation for t, and then I'll plug that in to the second equation. So all I did for this first one was just divide by s. So I get 240 divided by s equals t. So now I can plug this, because that came from the first equation, I'll plug it into the second equation. So where I see t, I'm going to put 240 divided by s. So here it is, it's this equation again, but instead of t, I have 240 divided by s. And now I only have s's in one equation, and I can solve for s. So I do have two different polynomials being multiplied, so this now could go to that factor and FOIL video that you could watch if you haven't seen it yet, because I'm going to have to FOIL these. So to do that, I'm going to multiply my first two terms. So s times 240 over s, the s's cancel out, I'm just left with 240. Then I'm going to take my outer terms, s times positive 2 is plus 2s. Now I'll take my inner terms, negative 20 times 240 over s gives me negative 4,800 over s. The 20 times 240 is 4,800. Then I take my last terms, negative 20 times 2 gives me negative 40, so minus 40. So this is my new equation. I notice I have the 240 on both sides, so I can subtract the 240 from either one, and they just go away. And that leaves me with 0 equals this part of the equation, 2s minus 4,800 over s minus 40, which is still really ugly, but we're going to solve that on the next slide. So I rewrote it up here. First thing I'll do is I'll multiply by s, just so that way I don't have a weird fraction in here. And that will give me still the 0, because 0 times s is still 0. This 2s becomes 2s squared. This, the s when I multiply by s, will go away, so minus 4,800 minus 40 times s, so minus 40s. I can clean this up. First, I'm just going to reorganize it because I now have a quadratic equation, but I'm used to seeing something in the form of x squared plus something, x plus something. So I just flipped these two terms to give me 0 equals 2s squared minus 40s minus 4,800. Then I can realize that all of these can be divided by 2, because again, if I want to solve a quadratic, it's easier to do if the term in front of the squared is just a 1. So I can divide everything by 2 to give me 0 equals s squared minus 20s minus 2400. So now I have a standard quadratic equation. So I can solve this by factoring. I have a video on that. Or by quadratic equation. I have a video on that. You can also use your calculator if you know how to solve quadratics with your calculator. Not all of them have the tools to do that, but you could graph this and go find the intersects. So I will do this one by factoring. I'm not going to explain too much because I've got a different video on it, but if you were to factor this, you'd get 0 equals s minus 60 times s plus 40. Just a quick recap on that, what that means is these first two terms are going to give me the s squared, and I'm going to have to add or subtract something in both of these polynomials. And the two will have to multiply to give me this. So 60, or negative 60 times 40 does give me negative 2400. And you're going to have to be able to add these to give me the middle term. So negative 60 plus 40 does give me negative 20. That's where I got this. That gives me the solutions of 60 and negative 40, which is just going to be flip the sign of these things in here. So I have negative 60, that becomes positive 60. I have positive 40, that becomes negative 40. These are my two answer choices. Now, negative doesn't make any sense because I'm looking for a speed. He's not going negative 40 miles per hour normally. So the only one that makes sense is 60, and that'll be my answer. As you saw, very complicated. I don't recommend going through all this. You might even get to the part where you have, maybe on that previous slide, a really messy equation and realize, okay, this is going to be now much more complicated. I'm going to go plug in my answer choices at that point. Because you don't know up front how hard it's going to be. But it's good to know there are other ways to do those things. So hopefully this was helpful. Leave a like, subscribe, and I'll see you on the next one.